Have you ever thought about whether we're truly alone in the universe or if there's more to our existence than what we see? What if the James Webb Telescope finally proves that we live inside a black hole? Join us as we explore this groundbreaking news that will make you question everything you thought you knew about the universe. So what exactly are black holes? They're like something out of a nightmare. Sure, you might have seen them in sci-fi movies, but the reality is even scarier. According to scientists, they're not just pitch-black holes in space. They're actually massive amounts of matter squeezed into an incredibly small area. Think of a star 10 times more massive than the sun, all packed into a sphere the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for centuries, ever since they pondered objects in space so massive and dense that they could trap light. The most famous ideas about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a tiny, dense core. If this core's mass is more than 3 times that of the sun, gravity overwhelms everything else, leading to the formation of a black hole. Detecting black holes is no easy task since they don't emit any light. However, scientists have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it'll pull the matter towards it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can get torn apart, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, emit powerful gamma bursts, and even influence the growth of new stars in some areas while stalling it in others. But where do black holes come from? Picture this. A star, once magnificent and blazing, meets its ultimate demise in a spectacular explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached their celestial retirement party in a supernova blast. Smaller stars, when they die, transform into something called neutron stars, which are superdense but not dense enough to trap light. However, if a star is about 3 times the mass of our sun, it collapses under its own gravitational pull, forming a black hole. As these mighty stars collapse, something strange occurs near their surfaces. Time itself starts to play tricks. From the perspective of someone far away, time appears to slow down near the event horizon, the point of no return for anything falling into a black hole. It's like the star's clock ticks at a different pace compared to ours. Sometimes, when 2 smaller black holes collide, they combine to form an even bigger and scarier black hole. If a black hole teams up with a neutron star, they create a colossal nightmare that defies comprehension. Scientists have been grappling with the scale of these cosmic phenomena for years. Black holes come in 2 sizes, huge and small. There's a sinister mystery surrounding them that we can't seem to unravel. But here's the twist. Small is relative when it comes to black holes. Stellar mass black holes, remnants of massive stars, can be as large as 10 to 24 times the size of the sun. There could be as many as 10 million to a billion of them in the Milky Way alone. That's an astronomical number of black holes that could swallow anything in their path. But wait, there's more. Supermassive black holes are on the other end of the spectrum. They're millions, if not billions, of times larger than the sun. They exist at the center of large galaxies, including our very own Milky Way. It's like a gaping dark void that's pulling everything towards it. Renowned physicist Stephen Hawking talked about black holes in his lifetime. His lectures were always insightful, but some of his theories couldn't be confirmed due to a lack of necessary equipment. However, there's hope on the horizon. A single scientific instrument is changing everything, and we're not ready for it. It goes by the name of the James Webb Space Telescope, also known as JWST, and it's here to plunge into the depths of our universe. The JWST is no ordinary telescope. It's an engineering marvel, a testament to the potential of human ambition. Sure, we've launched other space telescopes before, and they've been doing their jobs just fine, but this bad boy is in a class of its own. The JWST makes the Hubble, which has dutifully served us for years, look like a mere speck in the cosmos. The price tag of this astronomical wonder is a whopping $10 billion. Yes, you heard that right. That's enough zeros to make your head spin. And get this, it took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, not to mention the invaluable input from over 300 universities. But let's not forget the risks that come with such a grand undertaking. I know this isn't a venture for the faint of heart. The JWST is venturing into uncharted territory, pushing the boundaries of what we know and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its minimum mission life expectancy of 10 years. Since its launch, the JWST has made many incredible achievements. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside permanently. During its journey, the telescope successfully unfolded its massive 5-layer sunshield and giant main mirror, both of which had to be folded to fit onto the launch vehicle. Now, after NASA has fine-tuned and calibrated it, the telescope is almost ready to go into full operation. One of the most exciting things about the James Webb Space Telescope was when NASA announced that it had captured its first images of starlight. The first image taken by the telescope was of a star called HD 8446, resulting in a mosaic of 18 scattered bright dots from a star's light captured by the 18 mirror segments located on the primary mirror. NASA released a new and improved image of HD 8446 in which 18 unfocused copies of the star were brought together in a deliberate hexagonal formation. Once the observatory successfully aligns the individual segments of the primary mirror, it will begin the image stacking process. This will bring 18 images on top of each other into one clear view. Thanks to its sophisticated technology, the JWST will help scientists investigate the early stages of the universe after the Big Bang. It will study what happened after the first stars formed, a period known as the epoch of reionization. This era refers to when neutral hydrogen was reionized, or made to have an electric charge again, by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are very difficult to spot because of the way they interact with their host stars. Its powerful sensors will be able to observe these planets in more depth, including in some cases imaging their atmospheres. Understanding the atmospheres and formation conditions for planets could help scientists better predict if certain planets are habitable or not. Apart from studying the assembly of galaxies, scientists will study galaxies to see how matter is organized on a gigantic scale. This, in turn, lets us see how the universe evolved. The spiral and elliptical galaxies we see today evolved from different shapes over millions of years. One of JWST's goals is to look back at the earliest galaxies to better understand that evolution. Scientists are also trying to figure out how we got the variety of galaxies that are visible today and the current ways galaxies form and assemble. However, most importantly, the James Webb Space Telescope will help us answer the most profound questions of all. Are we alone in the universe? And are we living inside a black hole? The JWST has already been on the hunt. And guess what? It found compounds called polycyclic aromatic hydrocarbons, PAHs, lurking around those gigantic supermassive black holes in 3 active galaxies. PAHs, these carbon-based molecules with ring-like structures, are like the goth kids of the universe. They're everywhere, from distant galaxies to comets in our solar system. Now, they're not just fascinating because they could be the building blocks of life, but also because they help astronomers track star formation. When ultraviolet radiation hits these PAHs, they go all flashy and emit infrared light, a sight that can be detected by the JWST's mid-infrared instrument, also known as MIRI. That's usually a sign that there are some hot young stars hanging around. But wait for the plot twist. A brave astrophysicist, Ismael Garcia Bernard from Oxford University, decided to take a peek at 3 active galaxies known as NGC 6552, NGC 731, the spookily famous quintet, and NGC 7469. These galaxies are millions of light-years away in the depths of darkness. Now, what Garcia Bernard discovered will make your hair stand on end. In those central regions where the black holes reign supreme, MIRI found an abundance of PAHs. Sounds good, right? Well, here's where it gets chilling. The radiation near those supermassive black holes twisted the PAH's very essence. It transformed them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs vanished into oblivion, like being depowered by the darkness itself. But wait, there's a glimmer of hope. The larger PAHs managed to survive because they found shelter within thin, dense gas-filled clouds. It's like they found their own protective hiding spots. So while supermassive black holes are supposed to gobble up everything around them, they leave some clues behind, like footprints in the cosmic sand. I know what you might be thinking. If black holes can do all of this, could it be possible that our universe is inside a black hole? Could the answer to the question that has plagued humanity for years finally be at our fingertips? With the James Webb Space Telescope, we may soon find out. The telescope will dive deep into the mysteries of our universe, and who knows what it will discover next. As the James Webb Space Telescope, JWST, begins its mission, it promises to revolutionize our understanding of the universe in ways previously unimaginable. Its advanced technology offers an unprecedented view into cosmic phenomena, potentially uncovering secrets that have eluded scientists for decades. One of the key areas the JWST will explore is the formation and evolution of the first galaxies. By looking further back in time than ever before, the telescope will be able to observe the early universe's conditions and the processes that led to the formation of galaxies. This research could provide insight into how the universe transitioned from a nearly uniform state to the rich tapestry of galaxies, stars, and planets that we see today. Understanding these early stages is crucial for piecing together the history of cosmic evolution and the origins of the structures we observe in the universe. The JWST is also equipped to study the mysterious dark matter and dark energy that make up most of the universe's mass energy content. Although these components cannot be observed directly, their presence can be inferred through their gravitational effects on visible matter. By observing the behavior of galaxies and galaxy clusters, the JWST can help map the distribution of dark matter and provide clues about the nature of dark energy, which is believed to be driving the accelerated expansion of the universe. This could lead to groundbreaking discoveries in our understanding of the fundamental forces that govern cosmic dynamics. Another exciting aspect of the JWST's mission is its potential to identify and analyze exoplanet atmospheres. By studying the light that passes through a planet's atmosphere when it transits its host star, the JWST can detect the chemical composition of these atmospheres. This includes identifying molecules such as water vapor, carbon dioxide, and methane, which are critical for assessing a planet's habitability. The ability to analyze exoplanet atmospheres in detail may help scientists identify planets that could support life and prioritize them for further study. Moreover, the JWST's high-resolution imaging capabilities will allow it to observe the detailed structure of star-forming regions. These areas, often hidden by dust and gas, are where new stars and planetary systems are born. By peering through the dust with its infrared sensors, the JWST will reveal the intricate processes involved in star formation and the development of protoplanetary disks. Understanding these processes is essential for comprehending how stars and planetary systems, including our own, came into existence. In addition to its scientific objectives, the JWST is expected to inspire a new generation of astronomers and space enthusiasts. Its stunning images and discoveries will capture the public's imagination and highlight the importance of space exploration. By showcasing the universe's beauty and complexity, the JWST will serve as a reminder of the vastness of space and our place within it. The telescope's mission is also a testament to international collaboration and the collective effort of thousands of scientists, engineers, and researchers from around the world. The successful deployment and operation of the JWST exemplify what can be achieved when countries and organizations work together towards a common goal. This spirit of cooperation not only advances our knowledge of the universe, but also fosters goodwill and collaboration among nations. As the JWST continues its journey, it will undoubtedly encounter new and unexpected phenomena. The data it collects will likely lead to questions and discoveries that challenge our current understanding of the universe. Each finding will build upon the previous ones, gradually constructing a more complete picture of the cosmos. In conclusion, the James Webb Space Telescope stands on the brink of uncovering profound truths about our universe. Its observations will extend our knowledge of cosmic origins, the nature of dark matter and dark energy, and the potential for life beyond Earth. As it ventures into the unknown, the JWST will not only advance scientific knowledge, but also inspire wonder and curiosity about the universe we inhabit. The journey of discovery is just beginning, and the telescope's mission represents one of the most ambitious and exciting scientific endeavors of our time.